A molecule is a chemical compound that's formed by the sharing of electrons between two or more nonmetals. Essentially a covalent bond, if you will. There are three types of formulas you need to know before we start talking about molecules. The first one's an empirical formula. This shows the lowest ratio of atoms. An example would be CH2O. There's going to be a ratio of 1 carbon for every 2 hydrogens for every 1 oxygen. That's the typical form of a carbohydrate. The second type of formula is called the molecular formula. This shows the number of atoms in a molecule. For example, in glucose, the molecular formula is C6H12O6. Notice the ratio is still a 1 to 2 to 1 ratio of carbon, hydrogen, and oxygen. But now we know that there are 6 carbons, 12 hydrogens, and 6 oxygens within one molecule of glucose. The third type of formula is called structural formulas. This shows the arrangement of atoms. Here we see glucose once again, but this time it shows the arrangement of the atoms within that molecule. So how do molecules form? Here we have 2 fluorine atoms, both having 7 valence electrons. They both need 1 electron to become stable, and neither would like to lose an electron. So instead of one transferring an electron to the other, they share both electrons and form a covalent bond between them. This has now become a molecule of fluorine. The same thing can happen with oxygen. Both of these have 6 valence electrons and need 2 to fulfill their octet rule. So instead of transferring an electron, they will share the electrons. At that point, 50% of the time, both of those electrons are with one oxygen and both the electrons are with another oxygen. So they take turns filling their octet. Nitrogen, being in group 15, has 5 valence electrons, which means it needs 3 to fulfill its octet. And since they both want to gain 3, they will share 3 electrons and form a triple bond, like so. Here's an example of formaldehyde. You'll notice that hydrogen has 1 valence electron, carbon has 4 valence electrons, and oxygen has 6 valence electrons. What happens here is that they all end up sharing electrons, and if you count them up, everyone's octet's full. Notice hydrogen only has 2 electrons associated with it, but that's because it only has 1 principal energy level, which only needs 2 electrons to fulfill its octet rule. All the others in the molecule have 8 around them. One shortcut method to show how these electrons are shared is to put dashes instead of showing the dots being shared. Like so. If you'll notice that each dash represents 2 electrons being shared. This is a much easier way to write it down. Just remember that there's not really a stick in between those two. It's just a position where 2 electrons are being shared. Let's talk about the length of bonds. You can have 3 different types of bonds between 2 atoms within a molecule. A single bond, which is the sharing of only 2 electrons, is the longest bond. When you get a double bond, now we're sharing 4 electrons, and it becomes a tighter bond and pulls the atoms closer together. And finally, a triple bond has a sharing of 6 electrons and is the tightest still, and will actually move the atoms much, much closer together. Another way to discuss the length of bonds is the size of the atoms. If I take 2 fluorines, which are very, very small, and they come together and form a covalent bond between them, they will become that close. The only thing repelling them are the other electrons within that atom. If you notice here, the distance between their nuclei is shown by the arrow. Let's take 2 atoms of chlorine, a much larger molecule than fluorine because it has more electrons in it, creating a larger electron cloud. When these 2 come together and form a covalent bond, the distance between their nuclei is shown by the arrow here. If you were to compare a molecule of 2 chlorines and a molecule of 2 fluorines, you'll see that the distance between the 2 fluorines nuclei is much closer than the distance between the 2 chlorine nuclei. Hence, the bond between 2 fluorines is smaller than those of chlorine.